In this video, we'll solve two problems using a plus b to the power n and a minus b to the power n. The first one is x plus 1 by x to the power 6 and the next one is 2x minus 3 to the power 6. Pause the video, try this on your own and then we'll do it together. Okay, so let's get started. We'll try the first one first, x plus 1 by x to the power 6. For this, let's quickly recap what a plus b to the power n looks like. So this is a plus b to the power n, and this is what we get when we expand it. This has four things. The first one is summation. This means that k moves from 0 to n, and as k moves, we'll get different terms. We'll actually get n plus 1 terms because we have n plus 1 values of k. Each term has a coefficient and a power of a and a power of b. When we expand it, this is what we get. Having the plus sign because we have a summation. Okay. So the coefficients are nc0, nc1, nc2 and so on. The powers of a are a to the power n, a to the power n minus 1 and so on. Power of b are b to the power 0, which is 1, and then b to the power 1, b square and so on. So what we need to do is, when we're expanding something like a plus b to the power n, we'll figure out the coefficients, we'll figure out different powers, and to get each term, we'll multiply these three things: the coefficient, power of a, and power of b. And then we'll add all of these terms to get the expansion. So let's do that. X plus 1 by x to the power 6. N is equal to 6 here. So we'll have the coefficients as 6e0, 6e1, 6e2, 6e3, 6e4, 6e5, and 6e6. We have 7 coefficients because 7 terms because 6 plus 1 is 7. We'll add all of them up because summation. Now let's look at the powers. The first is x. So x to the power 6, then x to the power 5, then 4, 3, 2, 1, and 0. Don't forget the 0. And then for the other one, we have 1 by x. That is 1 by x to the power 0, then to the power 1, then 2, then 3, 4, 5, and 6. So let's simplify things. 6e0 is 1, 6e1 is 6, 6e2 is 6 times 5, that's 30 by 2, 15. 6e3 is 6 times 5 times 4 by 3 times 2, so 6 cancels out, 5 times 4 is 20. And then 6e4 is again 15, and then we have 6 and then 1. There's a pattern, it goes up, peaks, and then comes down. So 1, 6, 15, 20, 15, 6, and 1. Adding the plus sign, x to the power 6 times 1 by x to the power 0. This is 1, so what we get is x to the power 6. Then we have x to the power 5 times 1 by x to the power 1, which means we're dividing x to the power 5 by x to the power 1. This is x to the power 4, then 4 by 2, that's x square, then 3 by 3, that's 1, 2 by 4, that's 1 by x square, 1 by 5, that's 1 by x to the power 4, and then 1 by 0, 0 by x to the power 6, that's 1 by x to the power 6. Now we simply multiply them. This is the coefficient, this is the power of x. So this is x to the power 6 plus 6x to the power 4 plus 15x to the power 2 plus 20 plus 15 by x square plus 6 by x to the power 4 plus 1 by x to the power 6. This is your expansion for x plus 1 by x to the power 6. Let's do the next one. For that, we need to see what a minus b to the power n looks like because we have a negative sign. So a minus b to the power n, that's the same thing, but here's the difference. Minus b. We had b first and now we have minus b. What this does is it gives us alternate signs. One positive, then negative, then positive, then negative. Let's see its expansion. When we expand a minus b to the power n, this is what we get. nc0 a to the power n, nc1 a to the power n minus 1, minus b to the power 1, and so on. Wherever we had b, now we have minus b. And we add them up. Okay, so the first term remains the same. Then we have this minus b, which makes this term negative, then positive, then negative, then positive, then negative. So basically alternate signs. So comparing a plus b to the power n and a minus b to the power n, we can say that roughly half the terms will remain the same. The rest of them, the other half, will have a negative sign. And which terms will be same? The ones which have even powers of b, like b square, b to the power 4, and so on. And which terms will have a negative sign? The odd powers of b. And we can't say anything about the last term because we don't know the value of n. If n is even, this is positive. If n is odd, this is negative. Okay, so now let's use this to figure out the second problem. This is 2x minus 3 to the power 6. N here is 6, so we'll use that for coefficients. 6e0, 6e1, 6e2, 6e3, 6e4, 6e5, and 6e6. This time, we don't have all positives. We have alternate signs. The first one is positive, then we have negative, then positive, then negative, then positive, then negative, then positive. All right, so final term in this case is actually positive. Let's look at A's and B's. Our first is 2x. So this is 2x to the power 6, then 2x to the power 5, 4, 3, 2, 1, 0. Don't forget the 0. And then we have 3 to the power 0, 3 to the power 1, 2, 3, 4, 5, and 6. Now let's simplify. Coefficients first. We have 1, 6, 15, 20, and then going down 15, 6, and 1. Don't forget the signs. The first one is positive, then minus, plus, minus, plus, minus, plus. Now let's see how much we remember the powers of 2 and 3. 2 to the power 6, that's 64. So 64x to the power 6, then 32, then 16, then 8, then 4, then 2, and this is power 0, so this becomes 1. Then we have powers of 3. So 3 to the power 0 is 1, then 3, then 9, then 27, then 81, then 243, and finally 729. Now to get the terms, we multiply these three things. The first term is 1 times 1 times 64x to the power 6. So that's our first term. Then we have a minus. Multiplying these three will give us 576x to the power 5. Then we have plus something, then minus something, then plus, then minus, and then finally plus. You can check your answer, check your calculations. This is how you solve a plus b to the power n and a minus b to the power n.